Hello there. Today we're going to be talking about surface tension. If you don't know what surface tension is basically when all the water molecules inside the water start to stick together. You might have seen this when you're trying to fill up a glass. You fill it up full way, but slowly you can see a little bit of a dome start to form on top of it. That surface tension, or the water molecules inside the water, is very sticky and they want to come together. Since they're coming together, the water is not spilling. Surface tension is basically when the water molecules stick together so much that the water's outer surface actually holds and does not disturb due to any external force. So I'm now going to be showing you guys an example of this surface tension. So as you see, I've got a paper towel, a penny, and some water. I just added food coloring so it would be more clearly visible. Now I'm going to take all this water and I'm slowly going to drop it one by one on the penny. 2, 3 drops, 4 drops, 5 drops, 6 drops, 7 drops, 8 drops, 9 drops, 10 drops, 11 drops, 12 drops, 13 drops, 14 drops, 15 drops, 16 drops, 17 drops, 18 drops, 19 drops, 20 drops, 21 drops, 22 drops. As you see, I'm at 22 drops and it's still created that dome. Let's see how much more drops it can hold. 23 drops, 20. Oh, well, it looks like it held for 23 drops before bursting, which is actually pretty impressive. I thought all the water would just escape out like that, but it turns out it actually lasted for 23 drops. Now, what I have here is some dish soap, along with that, different food coloring. I'm going to be adding some soap to this purple water, and we're going to be seeing if this soap water can break the record. Yeah, that's good enough. And now I'll be mixing it, but I don't want to create any bubbles or else, that will be really hard to see. I'm going to be doing the exact same thing as I did with the regular water, but this time, let's see if it can or break the regular water droplets record. Okay, got my water. I'm going to be pouring droplets in it. 3, 4, 5. As you can see, there's no dome forming on this penny. Let's see what happens next. So I'm on 3 droplets. I already did. 4, 5, 6, 7. Oh, looks like it's kind of breaking off. 7, 8. Oh, another one broke. 9, 10, 11, 12. Oh my god, a lot of these are dropping off when I put the water droplets on it. Looks like it was only able to last 9 droplets. So it turns out that the soap water was not able to hold as many droplets as the regular water. As you can see, the dome has not even formed, and all the droplets, as you can see from my pipette, all the droplets are just sliding off. See, that one just slid off. And that one, and that one. See, this soap water is not able to hold a lot of droplets. Instead, it's all breaking apart. I'm going to be comparing it with the regular water. I'm going to be putting it side by side so you guys can easily see it. For the soap water, it did not have a dome, so I'm going to be doing the regular water again, and I'm going to be showing you guys the dome. 5. It looks like I need more water. As you can see, the dome is already basically forming. I already did 20 drops and the dome is already forming. So regularly, if this was soap water, it would already be sliding, but right now it's not sliding. You can literally see the dome on top of the penny. Let's do soap water one more time and see if it slides again or not. All the droplets I'm putting is sliding off. So it turns out that the regular water was able to hold more droplets than this one. And finally, after 30 droplets, it falls. Well, this one, it only was able to hold 9 droplets before actually bursting. You guys understood about surface tension, and in this video what we were trying to explain here is the regular water is able to hold, has much more of a better surface tension than the soap water.